Hi dear students, welcome to VidyaVardhini Academy. In this video, we are discussing one of the trick in D and F block elements, that is to calculate magnetic moment. As you know, this question is a compulsory question in board exam and also in many of the competitive exam, this question can be asked. Right? First is magnetic moment refers to whether the given elements or the ions, whether they are paramagnetic or diamagnetic. If so, what exactly is the magnetic moment exhibited by those elements or ions, right? Let me first explain the formula here for magnetic moment, which is equal to mu, that is equal to square root of n into n plus 2 Bohr magneton. This is the equation to calculate magnetic moment of ions. For this, I am telling you what exactly you should do by taking one example, that is a Cu2 plus. Cu2 plus is given. You have to write electronic configuration for Cu. First, that is argon 3d10 4s1. But when we are asked to calculate for Cu2 plus, you have to remove 2 electrons, and always remember, whenever you are removing electron, you have to remove from the outermost orbitals. First I will remove from 4s, then I will be removing from 3d. 2 electrons removed, then the configuration will be 3d9 4s0. Now when we are taking 3d9, d orbital consists of 5 degenerate orbitals. In that, each electron we have to fill first in each of the orbital with one electron. This is according to Hund's rule. We have to fill the electrons first in each of the orbital, then only we have to pair it. D9 configuration leads to one unpaired electron. This unpaired electron is responsible for magnetic moment. Hence, the value of n is 1. On substituting the value of n equals to 1, we get 1 into 1 plus 2 Bohr magneton. Here it is a square root of 3 Bohr magneton, which is nothing but 1.78 value. Okay. The value of magnetic momentum should be written along with the unit, and the unit is Bohr magneton. What exactly is the trick to calculate magnetic moment? Instead of doing all this, right now I am giving exactly one trick which can be applicable for all the molecules as well as ions to calculate magnetic moment. Okay. When the configuration of D is equal to 1, or if the configuration is D9, then directly you can write the value of magnetic moment equals to 1.78. For both, the value is same. If the configuration is D2 or D8, see, whenever it is D8, the number of unpaired electrons will be 2. Mu value will be 2.8 Bohr magneton. If the configuration D3 or D7, then the value of magnetic moment is 3.8 Bohr magneton. D4 and D6 will have the value of magnetic momentum 4.8 Bohr magneton. D5, it will be having magnetic momentum equals to 5.9 Bohr magneton. When the value of D equals to 6, you have to write this in degenerate orbitals. Fill each orbital with one electron, then pair it. After that, you are getting 4 unpaired electrons. N value is 4, not 6. Okay, that's why this trick works very well with all the ions. You can follow this trick in order to calculate a magnetic momentum very easily. If you want me to explain any ions in detail, write down in the comment box. To know more details related to D and F block, follow our YouTube channel VidyaVardhini Academy. Thank you.